When a student first begins using an array for multiplication, they will often have to draw out the whole array. Draw out every square or draw out every dot. For example, if they were trying to solve the question, there are plums on display at the grocery store. The display rack has 18 rows with 12 plums in each row. How many plums are in the grocery store display? So the context helps them to want to draw the array because they've seen plums on display at the grocery store. So they will have to draw out the array 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And because I've drawn a lot of arrays, I know that I can draw, if I draw a plum right next to my last plum, that I'm going to have exactly 18 plums. When children first begin drawing arrays, they don't know this necessarily, and they will sometimes end up with their plums all over the place until they realize that organizing and keeping track of their drawing helps them out. And you can help them figure this out by talking about that in your Congress, drawing on the expertise of the children in your class who do have a systematic way of drawing the array, and asking them in front of their peers how they were able to draw such a neat and organized array, and they will gladly share their strategy with their peers. So I'm only halfway through my array, not even quite yet, and so you can catch up with me on the other side. Now your students might choose to count those circles, but what we really want them to do is group the circles into groups of products that they know. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have 10 rows with 10 plums in each row, hopefully your students would be able to tell you without counting that if there were 10 rows of 10, that there would be 100 plums in that part. And the ones who can't, you want to definitely get to this part in your Congress, and you can ask some probing questions of some of your students, such things as, is there an easier way that you could figure that out? Are there any organizations that might help you figure that out? Those kinds of things. So here we have 2 more rows with 10 in each row, which they will likely know is 20. And here we have 2 rows with 8 in each row, giving them the 16. And here we have 10 rows with 8 in each row, giving them 80. So once they've figured all of those out, then they can take the 100 plus 80. That would give them 180. 180 plus 20 will give them 200. And 200 plus 16 will give them 216. And so their thinking might progress something like that. What you'd really like to see with the array, as they get better and better and more comfortable, they do have to start out generally drawing all those out. All the boxes or all the plums or whatever. But where you really want them to get is to an open array, because the open array is far less work for them, less chance for error, faster, more efficient. But they do have to spend some time with that closed array, the one where they draw out all the boxes or all the plums in that case, before that they'll be ready to think about an open array. And in the open array, they don't draw in everything. But they can conceive of this being 18 and this being 12, and then saying, well, if that's 12, then this must, if there's 10 here and 2 here, and then 10 here and 8 here, then in this box there would be 100, and in this box there would be 20. In this box, which is 2 by 8, there would be 16. And in this box, which is 10 by 8, there would be 80. You can see how much more efficient that is. And then they would add up as they did before.